Hi, my name is Scott Simpson, and today I'll be talking about what is the difference between molarity, molality, and mole fraction. So when you're talking about colligative properties, oftentimes you're referring to these three, but you need to know what each of them are. They have a strict mathematical definition that we need to go and understand. So molarity is defined as capital M, so that's usually what indicates that you're looking at molarity. It's moles over liters. Molality is often shown as a little m, and it's moles of solute divided by kilograms of solvent. So, what is the difference between a solute and a solvent? Well, if we're looking at a solution, let's say we have our beaker here, and we toss in, and it's full of water, and we toss in a few specks of sodium chloride. Well, sodium chloride would end up being the solute, and the water would be the solvent. So basically you just go by solute, whatever there's less of, solvent, whatever there's more of. And then mole fraction. Mole fraction, you have to specify what species you're looking at. So we're just going to give a generic species A is equal to moles of A divided by moles total. So the total number of moles in the system. So we're going to actually do an example problem. So our example problem is going to be looking at HCl, so hydrochloric acid, which is a strong acid and readily dissociates in water. Let's try and determine the molarity, molality, and mole fraction of an aqueous solution. So we have an aqueous solution. Of 40% by weight HCl. This is often also sometimes called by mass. We'll talk about that in a second. And then we want to calculate the molarity, assuming our density is equal to 1 gram per milliliter. Calculate the molality, and then calculate the mole fraction of HCl. So we need to go through and do each one of these, but a lot of times I get students who are confused on where to even start on these things. Well, first off, you have to know what percent weight means. So what a percent weight means is you look at some species or some amount. So a percent is usually just defined as part over total times 100%. And that's a percent. Now a weight percent is mass of species divided by total mass of the system times 100. So wherever you see a percent by weight, it's always a good idea just to assume you have 100 grams. So we know out of 100 grams, 40 of those grams are going to be HCl. So assume 100 grams total. So 100 grams times 40% would end up just being 40 grams of HCl. Which means we're just going to also assume in our system that we have HCl and water. So the grams of H2O is going to be equal to 100 grams minus the grams of HCl. So in this case, it's 100 grams minus 40 grams, which ends up equaling 60 grams. So now we know the mass quantities of each one of our species. We just have to start to convert to moles now. Because in all of these problems, it's always a good idea just to convert to moles, and you have to eventually get there in order to determine molarity. So, in our first step, we're going to figure out the number of moles of HCl. So, we know we have 40 grams of HCl. And if you look at the periodic table, you can determine that there are 35.6 grams for every 1 mole of HCl. Be sure to label your values. It makes canceling out much easier, and you'll have a good idea if you get the correct answer or not. I'm sorry, this should have been 36.5. So, if you notice, our grams of HCl cancel. We should be left over with moles. And that gets us to a value of 1.10 moles of HCl. Now let's figure out how many moles of water we have. So that should be equal to 60 grams H2O times. So we know that there are 18 grams of water for every 1 mole of water. Let's look to see if our math is going to be right. Our grams are going to cancel. We should end up with moles, so we should be okay. We'll end up with 3.33 moles of H2O. All right, so now what we have to do is figure out our molarity. So we have pretty much all of our calculated values that we need. Let's erase this bit. So we want to know the molarity of the HCl. So we're on part A. Molarity is defined as moles over liters. Well, we have our moles, but we need to figure out how many liters we have. And if you remember, when I introduced the question, we assumed our density was going to be 1 gram per milliliter. So we have a total solution of 100 grams. So let's convert this to liters. So for every 1 gram, we have 1 milliliter. So all we've done here is just converted to milliliters. And then we need to convert to liters. For every 1,000 milliliters, there is 1 liter. So going through, grams cancel out, milliliters cancel out, we should be left over with liters. And we'll end up at 0.100 liters. Now, notice how I kept 3 significant figures in each one of these calculations. Try to keep consistent with your significant figures. All right, so all we have to do now is just plug in. So we have 1.10 moles of HCl divided by 0.100 liters. This will end up leading to 11.0 molar HCl. So that's the concentration of our hydrochloric acid. Now, let's figure out our molality. Part B. So, molality is defined as moles solute divided by kilograms of solvent. So, we know our moles of solute, which is the hydrochloric acid, but we do not know the kilograms of solvent. So, our solvent is water, right? We know we have 60 grams of H2O. We need to convert this to kilograms, which is an easy conversion. All you do is divide by 1,000, because there are 1,000 grams for every 1 kilogram. So now all we have to do is just plug in and solve. So again, we have 1.100 moles of HCl divided by the number, or the amount of kilograms, so 0.0 kilograms. I'm going to erase this value over here, which ends up equaling 18.3 molal hydrochloric acid. Now, for the last part of our question, we have to just figure out the mole fraction. So that's relatively simple. Since we already have our equation for our mole fraction, and we already know our moles of hydrochloric acid and of water, all we have to do is plug in and solve. So, part C. We wanted to know the mole fraction of hydrochloric acid, and that's equal to the moles of HCl divided by moles total. And since we only have a two-component system, what I mean by that, we only have hydrochloric acid and we only have water. Our moles total can be expressed as the amount of HCl plus the moles of water. Now some students are tempted to just cross out the moles of HCl, but that's incorrect. That's not how it works. Due to order of operations, we cannot do that. So, all we have to do is plug and solve. So, we previously determined these values, 1.10 moles of HCl, 0.10 plus 3.33 moles of water. This ends up being 1.10 divided by 4.43, which equals 0.248. Now notice, I haven't put any units for my mole fraction. Mole fractions should not have units because we have moles on top and moles on the bottom. So what this essentially equals is moles divided by moles. So those units should end up canceling out, and we should end up with a unitless number at the end. So I hope I've been clear on explaining what's the difference between molarity, molality, and mole fraction, which you may need to use for different parts of colligative properties, such as Henry's law, partial pressure, things along those lines. If you have any questions, please let me know, and thank you very much.